Hello everybody, welcome into another lesson. So today we are going to solve systems of quadratic equations, which we're only going to do 3 of them and it's really not too bad. So let's say we have y equals x squared and then we got y equals x squared plus 3. So you have a system of 2 quadratic equations here. Just like with linear systems of equations, the idea is geometrically we're solving for where these 2 parabolas intersect. And largely with solving quadratic systems, you want to use substitution a lot. You'll end up using that. So let's say I use some substitution here, and I set one quadratic equation equal to the other. So I'll take x squared plus 3 and just set that equal to x squared. Well, that would end up giving me 3 is equal to 0, which we know isn't true. Just like with linear systems, if you get a false statement, that means there's no solution, which means these 2 parabolas actually don't intersect at all. This one has no solution. They don't intersect whatsoever. Now I got about 2 more. So these are relatively simple. If I could quit dropping crap. Alright, let's say y equals negative 3x squared, and then we get y equals negative 1/2 x squared minus 5. So again, use the substitution and set one quadratic equation equal to the other. So let's take that negative 1/2 x squared minus 5, set that equal to negative 3x squared. Well, let's get the right hand side equal to 0. If I add 3x squared to both sides, that would end up giving me 5/2 x squared minus 5 on the left side would be equal to 0. So simply put, 5/2 x squared would equal 5. Solve for your x squared. Well, we'll get 5x squared equals 10, which would give us that x squared equals 2, which means x would equal plus and minus square root of 2. So we got 2 solutions for x, which means technically we're going to have 2 solutions for y. Well, we might have one solution for y, but it's still going to be 2 separate coordinates, because if I take and I put in, if I take a square root, and whether it's positive or negative, and put it into either one of these here, I'm going to get a positive number back, right? So now, you just like with a linear inequality, you'll take your x value and you'll put it into one of these quadratic equations. Well, if I put in whether it's plus or minus the square root of 2, so negative 3 times the square root of 2, that quantity squared, what does that give me? That would give me negative 3 times 2. And even if I put in the negative square root of 2 and squared it, I'd still get positive 2 inside the parentheses, which would give me an outcome of negative 6 for both of them for my y value. So that means the parabola intersects at 2 points, at both plus and minus square root of 2 for my x coordinate, and then at negative 6 for my y coordinate on both of those. So those are the 2 points where these 2 parabolas would intersect, plus and minus square root of 2, negative 6. I'm only going to do one more because the rest of them get downright awful. Because there are some where you'll be completing the square and using the quadratic formula, and then you got to take it and substitute it back into the equation. which I don't think anyone wants to expand that to the second power, a solution using the quadratic formula. No thank you. Let's say we had y equals x squared plus 2x plus 1. And then you got y equals x squared minus 4x plus 4. So you got y equals x squared plus 2x plus 1 and y equals x squared minus 4x plus 4. Well, definitely again take one equation, set it equal to the other. So x squared plus 2x plus 1 would equal x squared minus 4x plus 4. Well, let's try to get the right-hand side equal to 0. That's going to look like 6x minus 3 equals 0. We killed off the x squared term, which makes it easier. We only have an x to the first term now. So this would turn into 6x equals 3, which means x would equal 1/2. So we only have one point where these parabolas intersect, and sometimes you'll have that. Nonetheless, though, let's put in 1/2 into one of these equations here. I'll do it with the top one. So if I take 1/2, raise that to the second power, plus 2 times 1/2 plus 1, that's going to give me 1/2 to the second is 1/4, plus 2 times 1/2 is 1, so 1/2 plus 1 plus 1 would end up giving, 1/4 plus 1 plus 1 would give me 1/4 plus 2, which would end up giving me 9/4. So the y-coordinate of the point of intersection is 9/4. So these two parabolas intersect at one point, at the point 1/2 and 9/4. So that's doing these by hand. Largely, if you're going to try to solve systems of quadratic equations, you probably want to use a graphing calculator, because you can get some ugly decimal and radical answers that, let's say I had to use the quadratic formula to solve one of these, to solve this rather, and it didn't reduce. Would you really want to expand a solution with the quadratic formula to the second power and then distribute it by 2 and then add all that up? Heck no. But that does sometimes happen. But the takeaway is, if you have two solutions for x, you'll technically then have two coordinates for the points of intersection. You'll have 2 points of intersection. If you have one coordinate for x, you'll have 1 point of intersection, so you'll have one y coordinate also. If you get a false statement where one side just doesn't equal the other, that means they don't intersect. And then if you got a true statement, one side equals exactly the other, like 3 equals 3, that would mean they're literally the same parabola. That's all that would mean. They're literally the same thing, that they overlap. So that's it for this lesson. Next lesson we will delve into graphing systems of quadratic inequalities. So I hope everyone has a great day. Take care.